This is Module 3, Lesson 6, Solving Linear Inequalities. So the first thing we're going to do is we're going to consider this first inequality, x is less than 1. Now, two values for which the inequality is true are 0 and -5. Now, there are infinitely many values that this works for, so we want to be able to graph it so that we can kind of include all of those values. So this is what the graph looks like. It has an open circle at the number 1, and then it goes, we put an arrow to the left. Open circle because if x is equal to, let's say, 0.99999 dot dot dot, okay? That is still less than 1, right? So we want to get to close to 1, but not there. So an open circle indicates that you do not want to include the value. A closed circle like that means to include the value. Okay, for an open circle, you guys, it's going to be greater than or less than. For a closed circle, it's going to be greater than or equal to or less than or equal to, because you want to include that value. And the third thing that we're going to talk about is writing the solution as a solution set. And it looks kind of corny, but it's going to be x. That bar means such that, which is why I love math, because one bar can mean two words. X is less than 1, and it's read the set of all real numbers such that x is less than 1. That's how it's read. Now we're going to consider what we call a compound inequality. That means x is between -3 and 1. Now you'll see that x can be -3 because it says x is greater than or equal to -3, or just this piece says -3 is less than or equal to x. And x also has to be less than 1. So it has to fulfill those two conditions. So I picked two values here, 0 and -2. Yeah, they're between -3 and 1. And the graph looks like it has a nice solid dot on -3, a nice open circle on 1, and we want those values in between, so it's darkened in between. And then we write the solution set in set notation. Again, those little squiggly set lines, x, that bar, and then we just put the compound inequality in between those and the bar, and you're done. And that says the set of all real numbers such that x is greater than or equal to -3, yet less than 1. Now, for solving inequalities, in other words, when we're not just given a plain old statement where x is hanging out by itself and then there's another number on the other side of the inequality symbol, we have to do a little work. So it's extremely similar to when you solved equations. It's wicked the same. There's only one teensy thing, is when you multiply or divide both sides of an inequality by a negative number, the direction of the inequality sign must be reversed. Okay, let's take a look at A. So what I'm going to do is I'm going to kind of pretend that it is like a regular equality, just knowing in the back of my mind that extra thing that I just told you about. So here we go. I'm going to subtract 3 from both sides. So -x is less than or equal to 6. Now I haven't multiplied or divided by a negative number, but I am going to now, because there's a -1 in front of the x. In order to get it to be a regular x, I'm going to divide by -1 on both sides. So x is going to be greater than or equal to -6. Now let's graph this. So we're going to put a nice solid dot on -6. And since x has to be greater than negative 6, we're going to go like, if I owe you $6, owing you no dollars is better than that. So we're going to go to the right. And so there it is. Now, let's state the solution set, and let's check to make sure we're right. So here's the solution set, x such that x is greater than or equal to negative 6, and then I end that cute little bracket thing, and I'm done. Now here is the deal. Let's do a mini check on this. Here's my original inequality, excuse me. Less than or equal to 9. So I'm going to just pick a value in this arrowed range here, and let's put 0 in because it's wicked easy. 3 minus 0, is that less than or equal to 9? True or false? Is 3 less than or equal to 9? That's true. It checks. Yay! Okay, now let's do the next one. Okay, so let's start out distributing. So we're going to have 12 minus 6y is greater than or equal to 12. I'm going to subtract 12 from both sides. So we get negative 6y is greater than or equal to 0. I'm going to divide both sides by negative 6, and I'm dividing by a negative number, so that means I have to change the sense of the inequality, is how it's called, or reverse the inequality sign. So less than or equal to 0, because 0 divided by negative 6 is 0. So we need a closed hole at 0, and we want to go to the left, because that's when less than 0 is. And then if we want to write it in set notation, we'll say y such that y is less than or equal to 0, and we're done. Now we can check this by putting in any value, 0 or to the left of 0. I usually do not pick the endpoint. I pick something that's not on the endpoint. So like you can pick negative 3, and then realize when you put that in, it will work. Let's do the next one. Again, we're going to distribute through, and just be careful about our distribution. So it'll be 2x take away 6 is greater than 1 take away 3x, and then negative 3 times a negative 5 is a positive 15. We're going to combine like terms, so 2x take away 6 is greater than 1 and 15 is 16, so negative 3x plus 16. So I'm going to add 3x to both sides. So I'm going to get 5x minus 6 is greater than 16. So I'm going to add 6 to both sides. So we're going to have 5x is greater than 22. So x is greater than 22 fifths. Notice how I didn't change the sense of the inequality, or I didn't reverse the inequality sign, because I had nice positive values in front of the x, so I didn't have to change the sign. Now how to graph this? Well, I'm thinking 5 goes into 22 4 times with 2 left over, so it's 4 and 2 fifths, which is between 4 and 5, a little bit closer to 4, and we'll have to do an open hole. So 4 and 2 fifths, do an open hole. X is greater than that, so I'm going to go to the right, and I'm going to kind of smush it in there, but you can write 4 and 2 fifths above it, so that you know that's where that open hole is. And again, set notation will be x such that x is greater than 22 over 5, and your parens. Very good. Let's go on to the next slide. We're going to start by solving this compound inequality. So we're going to kind of do two things at once, because really what this means is negative 3 is less than 2x plus 1, and then 2x plus 1 is less than or equal to 7. But I don't want to solve these separately. I want to be able to do it all at once, because I'm a little lazy. So I'm going to kind of erase this. Yay. Okay, and then we're going to start from scratch here. Now, I'm going to rewrite this a little bit to make it bigger. Okay, so here we go. First, we're going to deal with the plus 1. To get rid of it, we're going to have to subtract 1. And we kind of get it over here, no problem. But I also have to subtract 1 over here because I'm solving two inequalities at once. Negative 3 take away 1 is a negative 4. These will add out 6. Okay, now I just have to divide by 2. And I don't have to change any of the inequality signs. So I'm going to get negative 2 is less than x is less than or equal to 3. Then, of course, I'm going to graph it. I'm going to have an open circle on negative 2 because it's strictly less than, a closed circle on 3, and then I'm going to fill it in between. And then I'll write it in set notation. X such that, and just say negative 2 is less than x, which is in turn less than or equal to 3. Bada bing, done. And we've solved a compound inequality. The next one is just to solve this cute applied problem. It says a student scored 74, 80, and 94 on 3 algebra tests. What must he score on the 4th test in order to have an average grade of at least 85? So I'm going to let x equal his 4th test score, because that's what we really want to find out. What is the lowest test score? And then we're going to write the solution as an inequality. So here we go. So how would I average them up? Well, I want his average to be at least 85. That means greater than or equal to 85. So now all we have to do is come up with an expression for the average. Well, that's wicked cinchy, because you add up all the scores of the whole 4 tests and divide it by 4. That's going to be his average. So it's going to be 74 plus 80 plus 94 plus this other test score that we have no clue what it is. If we add all those up and divide by 4, I need them to be greater than or equal to 85. Okay? So we're doing super great. It has a fraction in it, kind of, has a little denominator. But we know how to get out of that because we've solved linear equations with denominators. We have to clear that fraction and multiply both sides by 4. So we'll get 74 plus 80 plus 94 plus x has to be greater than or equal to, because if I multiply both sides by 4 here, there we go, we will get these 4's to divide out, because 4 divided by 4 is 1. And 85 times 4 would be 340. Good? So once we get that, we're going to add up 74 and 80 and 94. Well, 74 and 80 is 154 plus 94 plus x. Sometimes I'm a little slow at adding, so I'm just going to add slowly so I don't make any mistakes. 154 plus 194 is 248. And then I'm going to subtract 248 from both sides. It's getting a little messy. Let me erase that, you guys. I'm just going to go E. There we go. Pen back. 248. So x has to be greater than or equal to, let me do a little cleanup here. There we go. I'm going to subtract this. 92. So he must score at least a 92 to get at least an 85. You know what killed him? It was the 74 killed him totally. Now you can proceed and do your worksheet on this lecture and then my math lab assignment. Good luck. If you have any issues, talk to your teacher.